Welcome to Chapter 2, Section 4, Solving Equations with Variables on Both Sides. Previously, you had 4 steps for solving multi-step equation. Now we have 5. I want you to take a quick look at these and see if you can determine what has been added. That's right, step 3. Move the variable to one side. Occasionally, you'll have a variable on both sides of the equal sign. When that happens, you have to move it to one side so you can isolate it to get alone. I would like you to take a moment and write these steps into your agenda so you have them to refer to. If you don't have your agenda with you, go ahead and put them in your notes and you can copy them into your agenda tomorrow. First, we use a distributive property. Well, there's nothing here that requires a distributive property. So we go to step 2, combine like terms on both sides. Well, here I have a variable term and a constant and a variable and a constant. So there's nothing to combine because I'm looking at both sides of the equal sign. Now I need step 3, move variable to one side. Well, in general, if you can move the smaller of the variables, it moves a little better. You don't have to deal with so many negatives. So I'm going to move my 2x because that's a bit smaller than the 5x. Remember, you can do anything you want as long as you do it to both sides. So on the right-hand side, I have 14. On the left-hand side, I'll have 3x plus 2. Now I need to go ahead and undo, because remember, I'm still isolating this x, so I need to get things rid of that. So I'm going to undo my addition and subtraction. So I'm going to subtract 2. So I have 12 equals 3x. Then I'm going to undo my multiplication division. That's 3 times x. So I'm going to divide by 3 and get x equals 4. Now I could go ahead and put this 4 back in here to see if this is a true statement. And I think you will find, whoops, that's a 4, that it is a true statement. On the left you have 22, and on the right you have 8 plus 14, which is also 22. So I know that x minus 4 is a true answer. Example 1, this is the first one that's required to be in your notes. We have 4 steps here we will take part in. The first one is use distributive property to get rid of parentheses on both sides. So we're going to go ahead and do that. And this will become 10x minus 2 equals 3x plus 33. So that one's done. Now we're going to combine like terms on both sides. Well, in this case, there's no like terms on either side to combine. So move on to step 3. Move variable to one side. I'm looking at my variables and I have a 10x and I have a 3x. Since the 3x is smaller, I'm going to move the 3x. It doesn't really make the difference which one you move, but if you pick the smaller one, you're dealing with less negatives, typically. These cancel, so on the right I have 33. On the left I have 7x minus 2. Now I'm going to undo the addition subtraction. So I'm going to add 2 to both sides. So I have 7x equals 35. Then I'm going to undo the multiplication division. As you see here, this is 7 times x. So I'm going to divide by 7, or multiply by 1/7, so that x equals 5. Now we've talked a bit about this before, but I'm reminding you, dividing by 7 and multiplying by 1/7 is the same thing. Now you should always put your 5, your answer, in this case 5, back into the problem to see if it works. 2 times 24, which is 48. On the right, I have 3 times 5 plus 11, which is 3 times 16, which is also 48. Since 48 equals 48, I know that 5 is my solution. I know story problems always cause a lot of stress, but let's take a look at them and see if we can decrease that stress just a bit. In this diagram, we have information about populations of 2 towns. We have town A, which starts at 3,225, but has a yearly growth of 100 people. We have town B, which starts slightly greater at 3,300, and its yearly growth is 75 people. when creating an equation, we need to ask ourselves what's staying consistent and what is changing, or what's a variable. So taking a look at this, looking at town A, we see that we have a constant of 3,225. That's not going to change. That's going to stay constant no matter what. What changes is the 100%, silly me, 100 per year. In town B, we have a constant of 3,300, and our variable is 75 because that depends on the year as well. And we want to know when they're equal. Now we can take a look at this and hopefully solve it to determine how many years it will take for them to be equal. In our rules, we look for any distributive property to apply. We don't have any. And then we try to get our variables on one side. Again, I'm going to move the smaller one to stay away from negatives if I can. So I have 3,225 plus 25y equals 3,300. Isolate my variable by adding and subtracting. So I'm going to have 25y equals 75. Divide both sides by 25 to isolate the variable. We're in the addition last step, the multiplication step. So I have y equals 3. So in 3 years, their populations will be equal. Another example. This is going to be example 2 in your notes. Again, make sure you're asking yourself at story problems, what is consistent and what's changing, because that's probably the variable. So I'm going to rise this up a bit, and I'm going to write number 2 so that you know this has to be in your notes. And here we go. It takes a graphic designer 1.5 hours to make one page of a website. Using a new software, the designer could complete each page in 1.25 hours, but it takes 8 hours to learn the software. How many web pages would the designer have to make in order to save time using the new software? Well, your web pages is your variable. And we realize that in the first part of this, we have 1.5 hours to make one page of a website. So that's 1.5 times W. But in the second part of this, with the new software, each page could take 1.25 hours. So that each page is 1.25 hours per page, but it takes 8 hours. Now the 8 hours is your consistent. So it's your constant in the equation. And then let's go ahead and solve this. There's nothing to distribute. So we now get the variables on one side. Again, I'm going to move the smaller of the two because it's usually the easiest way of doing this. 0.25W equals 8. Then there's no addition subtraction to do. So I'm going to go straight to undoing the multiplication division. So I'm going to divide by 0.25, divide by 0.25. So W equals 32. Now, instead of dividing by 0.25, I could have multiplied by, remember this is 1/4, so I could have multiplied by 4. Because 4 times 0.25 would have made a 1 W. 4/4, 4 times 0.25, and that would have given me the same answer. How many solutions? Is that not the question to ask? So far, all the examples we've done have only had one solution. But it's possible for an equation to have many solutions or no solutions. So we have 3 choices: 0 or no solutions, 1 solution, or many solutions. Let's look at each of those cases. We have our first definition in this page. This needs to go in your notes. This would be your third item you must have in your notes. Identity. An identity is an equation that is true for all values of a variable. This is the definition you need to have in your notes. For example, this equation is an identity because 6 does equal 6. Notice up here, 3x plus 6 equals 3x plus 6. So an identity is true for every value of x, no matter what the value of x is. Number 4, required item in your notes, is also a definition. An equation has no solutions when the sides of the equation are not equal. This is the example I've given you. 2 is never going to be equal to 4. No matter what the value, x plus 2 is never going to be equal to x plus 4. So this equation has no solution because it doesn't matter what your value of x is. It cannot be made true. I apologize if this is a bit tough to read, but this is 5, 6, 7, and 8 in your notes. I want you to try to solve each of these equations. I think you can do it. And then for problem 8, tell me which equation has many solutions, one solution, or no solution. And you probably want to solve those first. What has become common, I would like you to take a moment and judge your own learning. Verify that you know both vocabulary words, and also check yourself on how well you can solve equations with variables on both sides. And I will see you in class tomorrow.